Hello, good morning, everyone. We are waiting on Yates to join us. We might just have a fireside chat with me. Maybe I could take some questions in the question box. Let's see who is here. All right, a handful of folks. Some of the topics we were going to talk about, I can list some of the topics we were going to talk about, and maybe we can start getting some conversation going in the chat box. So we can, if Yates joins us, we can look at those, or if not, we can talk about them amongst us. So the first thing we were going to talk about is how has the connected vehicle market been changing and growing in the past few years? And we're going to talk about some of the different types of technology and what their likelihood of uptake is. That's question number one. So if anybody has any good thoughts on how has technology been changing and growing. So for example, where might we see some of the quicker uptake? Do you think we might have more integration of data that is more telematics based, that has higher latency, integrated with some of the lower latency data? That's something that we're seeing in the marketplace right now. So there's some more coordination of data and technology on the receiving side than there is on the roadside units. Does anybody have any good thoughts about that? I can share with you what I'm seeing. So one of the things that we're seeing is the growth of the telematics data. Some people call that small c, small v, as opposed to connected vehicle with a capital C and a capital V, which would be related to directly from a vehicle, from an infrastructure in a DSRC or CV to X type system. We've been seeing the growth of some of the telematics equipment, some of the telematics data directly from vehicles. Almost all new vehicles have 4G capability built into them, thereby being able to share a lot of points of data about themselves, similar to a DSRC or CV to X scenario, but instead more pervasively deployed across a whole fleet. Almost all new vehicles have that capability set. And from what we've heard from vendors, that has a little bit of a latency, operating somewhere between 5 seconds delay and 4 minutes delay. Kind of depends on who we talk to right there. And which makes that data really challenging to use for safety applications, but a great, interesting way for operational use, and also for certainly for our planning team members. So that was a trend that we were going to talk about here with Yates. Let's see, and I have some questions and answers here. Let's see. Oh, thanks, Justin Johnson, for teeing me up, throwing me that softball. That's pretty exciting. Justin's question is related to tolling in connected vehicles. And before I start to answer that question, let me tell you, Justin Johnson has a panel up next. And Justin Johnson is the man. And Jason, look at you jumping in. Woo! With a yellow background. That's my favorite color.
You know, I did not pick out this color, but I think I'm going to go for something sort of a little bit different, maybe Omni Air colors for our next virtual workshop.
I like it. It's perfect.
So I suspect Yeatland is having some connectivity issues, and that's quite all right. So what I thought I would do is maybe turn the tables here and interview you. I see you're dressed in the proper colors, and we appreciate that. I need to pull my Omni Air shirts out of the closet. That's great. Well, so tell us this. You've been involved in Omni Air, you know, as long as anybody I know, right? You started out as a board member of Omni Air Certification Services. You progressed to the executive director role, and then to the full Omni Air board role, where you're now a distinguished board member. You know, maybe just give us your perspective on Omni Air and our mission and how that's evolved over time, and you know, what changes you've seen, and maybe how that reflects some of the changes in the connected vehicle market.
I will talk about changes. Jason, thank you for that question. I'm going to. Do you mind if I answer Justin's first? Because I started to right when you jumped in.
Sure.
And I also want to remind everyone that Justin Johnson has a session up next. And by the way, Justin Johnson is amazing. If you ever get to talk to this guy, I've never met, there are very few people I know who are so capable at everything. Both of their names are Justin, but one of the Justins is up next. So if you get a chance to go to his panel, which is coming up next, please do that because he's amazing. In fact, he was the first person to try to bail me out of my one-sided Fireside chat here. That's how quick and capable that guy is, and with a really great question. So for connected vehicle for tolling, right, because that's a question that we've been working on since I joined CAPS, and that was, man, a long time ago. I was one of the first people in the US hired by CAPS. And the mission then was to try to shift tolling to a connected vehicle environment. And so then I can tie that into Jason's question too. We've finally shifted to a place where we can, where we're close to being able to do connected vehicles, use connected vehicles for tolling. So equipment directly installed in the vehicle at the factory to do safety applications can also be used to do tolling. And so I'm the chair of the SAE committee to develop a standard for that. And so we're very excited to work with Ford, who's a heavy participant in that effort, and other members to look at how we can do tolling and other types of financial transactions directly from in-vehicle-based equipment. The opportunity for this is that agencies and any agency who takes payments, who takes over-the-air payments, or maybe who want to take over-the-air payment, will be able to do that without also having to manage toll tags. For some agencies, they're less concerned about managing toll tags or tolling equipment in the vehicle, but for many agencies, that's an enormous concern and a heavy lift for them, managing that inventory of tags and stickers. So this is a great opportunity to be able to do more over-the-air transactions. Also with the precision of connected vehicle equipment, it allows us to do very precise tolling and payments so that we can do express lanes payments, we can do parking payments, all kinds of precise detailed level payments. Thank you for that incredible, awesome question, Justin.
Oh, look who we
and then
have
Yates
here.
is here. Hey, it's good to have you.
Hi, I seem to be having some technical difficulties on my end here.
That's all
Well,
right.
you're
I was going to substitute for you, Yeatland, and talk about Canada, but I think you're much better positioned to do that. I tell you what, folks, I am going to drop and let you guys have this great conversation. And good luck, and we'll talk soon.
Sounds good.
All right. So we were talking about the CV market. We were just talking about tolling with connected vehicles, which you and I hadn't discussed before, tolling. Mm-hmm. But we could talk about other types of data. And that would be related to telematics data. So what are you seeing in Canada where it comes to different types of tolling technology in the market for that developing, or different types of connected vehicle market developments?
Well, I think one of the things that will be a little bit of a recurring theme that we're going to have here with some of the things in Canada. Definitely, it's always a bit. Canada's always a little bit behind, compared to the U.S. In the tolling market, particularly within Western Canada, I just haven't seen that much that much tolling. There's a bit of a resistance in general to tolling. Over here in Alberta, there's zero tolling as far as I know. Like it just hasn't been happening. I've had some conversations with some of the clients over here in Canada and some of the governments, and definitely. I think similar to the where the U.S. was a little while ago with RFID and CD. I think that's tolling. I kind of think it's probably going to be inevitable, given that with the reliance on fuel taxes. It's but we're still not there yet in general.
How does that work, Yates? You and I didn't discuss this. I'm happy to learn. Is the Canadian fuel tax system the same as the U.S.? Are you familiar with the U.S. system? Is it different? And and you know, what are the kind of nuances in that that may make connected vehicles or payment systems different in Canada? Road use charge, for example.
So I'm not entirely familiar with, and definitely tolling is further away from my area of expertise. So I'm less familiar with how tolling works in the U.S. In Alberta, for example, you know, you have your fuel tax on top of, or your you know, per liter has a X amount of cents per liter goes towards the Alberta government, and that largely funds the you know, the roads and infrastructure over here, and portion of that goes down to the municipality as well. And you know, of course, the more kilometers you drive, the more you're contributing towards that infrastructure. So you know, and of course, as I'm sure you've discussed, is as electric vehicles become more and more predominant, we're going to have a lot less available money for fuel taxes.
Yep, same situation. I'm glad I didn't know that in Canada, so that's great. So let's see, we were going to talk about, I think the next thing we had on our list was shifts in technology and what's coming in the future. And I probably should have taken that while you were offline, but so I was going to take a couple minutes to talk through that. And Yates, you can comment on that, and then the next question is yours. So originally we started off with DSRC. We have a nice graphic for this too. In around 1999, in November of 1999. Since then, we and DSRC was probably one of the first safety technologies ever that required the interaction of state DOTs, federal DOTs, and automotive OEMs, right? So because we had safety equipment like seatbelts, it's kind of localized to the car, so we don't need to have a large group of folks interacting together to make it work. And unlike connected vehicle DSRC, for example. So it took a little bit of time to get that going. And then, of course, since it's free and open to everyone through the U.S. government, there was all kinds of hiccups along the way there to get it off the ground. We're close to getting it off the ground. And about 4 years ago, that stalled. Enter CV to X, cellular to X technologies. Which we don't have all the tests done side to side. I think that the consensus of most folks is that cellular V2X is roughly equivalent to DSRC, depending on the particular application in terms of performance, although that's not highly quantified yet. And then also on the horizon, we have 5G forthcoming. I think the 5G's last announcement was was saying that the standards for automotive safety applications would be available somewhere in the 2023 timeline, but I may have that. I may have misread that. And it's likely that has to be backed by cellular V2X technology in order to do safety applications. So that's what we understand right now. And so we're looking forward to see how that shakes out. The changes I see coming will be largely determined by what the FCC says. Currently it looks like the FCC isn't going to make a decision about that until November, probably trying to take advantage of the election cycle to make sure that that everything is politically aligned with whomever is next. So so we'll see how that shakes out.
Yeah, and
are you seeing anything different?
Well, what I'm seeing over here in Canada is, in general, following very closely what's happening in the U.S., watching very, very closely to changes in the U.S. In the technology, and preparing for it. And there's it's fairly open-ended over here in Canada. with the, for example, with the active Aurora testbed that I'm working with in Alberta, you know, and I've been talking with representatives from Alberta government as well. You know, they're largely watching industry. They're watching the OEMs. They're watching what's happening in the U.S. You know, there is a desire to get out in front of this and try things out and deploy technology, and you know, and predicting what's going to happen in the future. So as we're watching the, you know, the changes that are happening in the automotive industry, yeah, we're excited. We're like going, oh wow, what's going to happen next? Let's try to predict it. But I get a general sense, you know, and this is purely my opinion, but I get a general sense that we're, you know, we're not driving the changes, the policy necessarily yet. We're not quite ready there, because, you know, you know, if in Alberta, for example, we were to say, hey, you know, DSRC is the way to go. This is the way. This is the technology. Here's all the reasons for DSRC, and you know, we start talking about owning the data and everything. The problem is that if the U.S. goes the opposite direction, you know, I suspect that we'd have problems fulfilling that mandate if we were to mandate it. You know, but that's just my general opinion.
Do you think that you have to have a mandate, Yates, if the U.S. has one? Does Canada need one too, or does that kind of naturally extend without having to have legislative action? Or regulatory action is a better way of saying that. So,
yeah, I don't know if you know, in general. So, for example, with I mean, let's look at ITS architecture. So, ITS, you know, U.S. has an ITS architecture. The for Canada, we took a look at that architecture and we said, gosh, that's a really good architecture. It's really well written. Let's adopt it. Let's just adopt the ITS architecture from the US. But we did it formally over here. We adopted it formally. And then we changed some of the language. We changed some of the spelling, you know, because, well, you have the incorrect spelling from the US. So we changed it to the correct spelling for Canada.
Right.
But yeah, that's, and so, you know, that, and in terms of bandwidths and things like that, you know, I suspect we're probably going to be doing very similar things as well.
Okay.
So we got a question from the audience over here, and I thought maybe let's deviate from our script and take a look at this one. It says, "What are your thoughts?"
I was about to do the same thing.
Yeah. What are your thoughts on virtual RSU tech? And it's very relevant to your discussions in here.
What question is that? Where are you seeing that?
Oh, in the chat here. What are your thoughts on virtual roadside unit technology?
I don't have a thought on that. I am also I want to see where this question is coming from, because I see the last one from Mr. Vanderzee. So virtual roadside technology. So I don't know a whole lot about virtual roadside technology. Do you know a whole lot about that, Yates?
Well,
have you done work in that space?
Well, I think what Mr. Chivetti here is asking is, you know, you don't have an actual. So instead of DSRC roadside units, you know, putting one every 800 meters or something like that, I think we're just talking about CV2X, right? What if you had you know, you didn't have roadside units and you just operate everything, say, out of you know, centralized nodes or perhaps a regional structure.
Right, and I do. I see it in the chat and not the Q&A. I got it now. So I might add on a little bit and say, yes, that cellular V2X does require roadside units. So we do need roadside units for CV2X, and maybe we can try to clarify that question more. But you know, maybe that goes back to our original question, Yates, about different types of connected vehicle technology or telematics technology versus roadside unit-based technology. So when the vehicle is communicating over a cellular network, 4G, for example, or 5G in newer models, directly with the automotive manufacturer. So, if that's what harsh means, I think that is fantastic. We talked to vendors who said that there is between a 5-second to 4-minute delay. It depends on who we talk to. So there's too much latency to do safety applications, and there but plenty and sufficiently latency to be able to do planning and to do some operational applications. So I think that it's fantastic for those uses, and it's also fantastic to give a more quick, granular level look at what's going on in the area, in addition to data from cameras and in-ground sensors and other vehicle type data. We can put together a really nice look at how traffic is operating in that area.
Yeah, and you know, I haven't. So I played a lot with the ESRC connected vehicle technology, but and I'm just starting to look at CV2X recently. So I mean, I guess you know, one thought that's out there is, why do you need a CV2X RSU? Why can't you just, you know, piggyback off of the local telecom in order to, say, get messages now? And I'm thinking about getting messages outwards, you know, and if you're piggybacking off of that, you're getting that message outwards from, say, for travel information systems. What's wrong with that?
Nothing. So, and I think, you know, that's largely the approach that will happen with 5G. I'll channel my inner Jim Lansford here because I see he's in the session. You know, that's one of the benefits of using a telecommunications-based system, is that it's already deployed, right? So the downsides are that number one is that we're not sure who quite owns the data. I mean, if it comes over the telecommunication provider's lines, then it's probably owned by Verizon or AT&T. And for many of our clients, they would prefer to own the data. They are used to gathering the data from their roadsides and then having access to that data without an intermediary. So that's one concern about that. And then the other concern for the time being is latency. And again, for mobility type applications, or for planning, or for some operations applications, yeah, the latency might be a problem. So those are some downsides to that, but I don't think that's and we also don't have solid standards for executing that. So I don't know if it will be done the same way everywhere. Yeah. And I think we have some great feedback on your discussion looking in the chat box, not the Q&A question, about the architecture. So thanks for that follow-up.
Yeah. And there's another comment here about you know, using SPAT over a cellular network, and you know, it's just, again, it comes down to exactly what you said, is latency. You know, for that end of it, for SPAT. I was like, are we going to? It's not that it's impossible, but you know, is my signal phase and timing data, is that something that I'd want projecting down to the future? You know, for CAV, do I want my automated vehicle getting SPAT information that just might be, you know, a little bit old?
Yeah, for SPAT, it might not matter as much because it doesn't change a lot necessarily, right? The signal phase doesn't change, but maybe if we have adaptable signals, then it becomes a problem. Right. But your point about latency is well taken. I do also want to make sure we address the last question, the Q&A box, which I don't think we got to yet, which was the question about insuring rural. Did you see that there, Yates? There's a lot of rural spaces in Canada. Have you had any experience looking at rural questions?
So I've been looking a little bit at rural areas. So the question is, what are the biggest challenges ensuring that smaller and rural areas are ready for connected vehicles? So, yeah, I've definitely worked a lot in this space over here, and I've been talking to a lot with the rural municipalities.
You have 3 minutes.
Okay, so what are the biggest challenges? Number one, funding. Number two, giant areas and large areas, and you want to be able to have enough connectivity over there. The infrastructure, getting the power out there,
That's right.
That's
power and comms.
Yep.
I'll in the 3 minutes that are left, I will augment what you're saying, and to the AECOM horn just a little bit, because we've actually been working on this lately. Dan Corey from our team we've developed a tool to digitally determine the value of having fiber in specific locations and including equity concerns with that. So we can look at the areas that are most needy and how we can try to get them funding, and how we can prove to US DOT with some quantifiable metrics about why it's really important to have connectivity, to have power and comms out there in order to enable connected vehicles. Right. So if we want to, so that's really cool to be able to look to include equity, availability, to include look at population, the amount of crashes, the amount of need for internet connectivity for schools and such. So if anyone has any questions about that, that's something we're enjoying right now.
We have, 1 minute left or so.
Yeah, something like that. So go ahead, Yates, because I took the first 10. So you wrap it up.
Well, I guess I'm going to say thank you to you, Suzanne. That was very enlightening, and I've had you and I have had a chance to chat a little while in the last little while, a couple of times. That's been a real pleasure. My apologies again for I had some issues getting online over here. I guess overall, I think to sum it up over here, connected vehicles extremely important to the rise of automated vehicles. There's a lot of uncertainty, and as you can tell, we're a lot of us are still out here looking to the future and seeing what's going to happen, and watching anxiously to the changes in technology, but also the changes in political, in the politics and regulations and policies as well.
Likewise, thank you, Yates, and also I want to quick plug Justin's session, which is up next.
Absolutely. Yeah.
Thank you, Jason. Thank you, Omni Air.
All right. Thank you very much.